All right, ladies and gentlemen, welcome back. So we're going to kind of make a connection here between your heart and your circulation today. And first off, just talk about another diagnostic tool, another diagnostic measure to look at how your heart is pumping and how well is it actually performing its job. So we talk about this idea of cardiac output. And really, this is just talking about the volume of blood that your heart is actually pumping into your systemic circuit every minute. So, what is it pushing out to your limbs, to your organs, to your head, to your brain? Um, and this measure really depends on two pieces. One, your actual heart rate or your pulse, how many beats per minute is your heart producing, um, as well as a factor of this thing called stroke volume. So, what's the amount of blood typically pushed in a single contraction? At rest, an average healthy adult will push about 5 liters per minute. So, take that times your heart rate, and you can figure out your approximate cardiac output. And there's a lot of things that will affect how much blood you're pushing based on different stimuli. So, are we talking about sort of short term things like exercise, um, just emotional trauma, right? You're upset, body temperature, um, excess sweating can also work there when you talk about lowering blood pressure. One of the things that you often come in contact with cardiac output, stroke volume, is if there's some sort of crisis. Uh, you're hemorrhaging, your body is producing excess epinephrine, which is what you probably know more better as adrenaline. All of that kind of stuff is going to cause changes to that stroke volume for good or bad, depending on what's going on. And that can give us some indication on how well your heart is actually doing its job. Is it having to pump harder or slower because of the amount of blood that's moving throughout your body? So let's talk circulation then. What does this actually mean? So when we talk about that circulation, it's your heart moving that blood to other places in your body, right? It's that flow of blood through your tissues to allow for the transport of those gases, those nutrients, and those waste products to get to and away from where we need them. Um, when we look at a typical mammalian system like us, then we typically are looking at three types of circulation, three circulation sort of cycles. Um, Remember, technically, we are considered a double circuit system, and that's because you've got two major circuits. You've got your pulmonary circuit going out into your lungs, and then your systemic circuit going to your body, both upper and lower. The third cycle here is just the circulation directly to your heart. And that's that coronary circulation. We'll talk a little bit about that as well. Just some interesting little tidbits of information here, right? Average person, anywhere from 5 to 35 liters of blood per minute, depending on age, size, health. Are you exercising? Are you resting? That kind of thing. So, anywhere between 5 and 35 liters of blood per minute is pretty typical depending on the circumstances. Um, and that means that we're moving blood through at least 60,000 miles of blood vessels. And again, depending on how big you are, we might be up to 100,000 miles. That's insane. Go Google how far it's going to take you to get between 60,000 and 100,000 miles away. Be pretty impressed. It does mean that we have to move that blood at least 100,000 times per day. So, talking heart rate here, to be able to move that blood and keep it in circulation, that's a lot of beats. And so, you're talking somewhere on the order of about 2.5 billion times over an average lifespan. And as people are living longer, that's even more. All right. And that also means you're pumping somewhere on the order of about 300 million liters. And for those of you who still prefer what we're used to here in the States, that's about 80 million gallons over your lifetime. That's a lot of blood, and a lot of places to move it. So how do we do it? So let's jump into your pulmonary circulation here first. And when we get to the second part of chapter 42, we're going to focus a little bit more here on this component of it. But for now, we're talking about the blood coming back from your body into your right atria, goes through your tricuspid valve into your right ventricle, and then we're going to push that out into your pulmonary trunk here. Okay, remember this is all low oxygenated blood, deoxygenated blood. um, and we're going to throw it up into that pulmonary trunk, so it goes through your pulmonary semilunar valve, and then it's going to move either to your right or to your left lung. Okay. Once that deoxygenated blood makes it down to your alveoli, right, those little air sacs, they kind of look like a bundle of grapes. Um, that's where the diffusion is going to happen because these are really thin-walled cells here. And we're going to cause the carbon dioxide to end up into the alveoli. Oxygen is going to end up into your blood. And then we're going to return that oxygenated blood back through the pulmonary veins, and we're going to enter back into your left atria. Once we get back into your heart, we're now going to go from that left atria through your bicuspid or mitral valve, down into your left ventricle, through your aortic valve, and then up into your ascending aorta to start your systemic circulation. So systemic circulation is now going to take that oxygenated blood from your heart out to your body, right? So your ascending aorta, the one that's kind of moving up before we actually hit the crest and actually make a turn, your ascending aorta is going to end up feeding your coronary circulation, so your heart circulation, all right? And then we're going to cusp over your aortic arch, and from your aortic arch, your major arteries are going to start feeding up into your shoulders, your neck, and your head. And then your descending aorta will actually come down the back of your body, kind of along your spinal cord, and start to feed the lower half of your body. So your sort of gut down, all right, your diaphragm down. So your major organs here in your body cavity down to your legs and your feet. We'll get to capillary beds, so really thinly walled blood vessels again. Those will then allow the diffusion of oxygen out to your tissue cells, will take back the carbon dioxide into circulation, and then will feed back to the heart again. So anything coming from basically your diaphragm down will feed back into your inferior vena cava, which will empty back into your right atria. Anything from your arms and above your diaphragm will feed back into your superior vena cava, and again back into your right atria. And then we start the whole circulation cycle back over again, where we end up in the ventricle and back out to your pulmonary circulation. So let's take it one step at a time. Okay, so we'll start in your right ventricle, okay, which is just emptied out of your right atria. So that oxygen poor blood is now going to get pushed into your pulmonary arteries that lead to your lungs. And we're going to get to that pulmonary artery, that pulmonary trunk, via your semilunar valves. Okay, so we're going to open up that pulmonary semilunar valve when that ventricle contracts. We're going to send that deoxygenated blood out into your lungs. Either it'll go right or left, depending on where it happens to land. Same basic principle happens either way. And we'll get to those capillary beds that surround your alveoli, those air sacs in your lungs. And we're going to load oxygen from your lungs and unload the carbon dioxide back into your lung tissue. You breathe out the carbon dioxide. We now have oxygen-rich blood, which will come back from the lungs and enter your heart at your left atria, okay, via those pulmonary veins. We'll go through your mitral valve, okay, when that atria contracts, filling up your ventricle, Once that ventricle is filled through that bicuspid or mitral valve closes shut, and that oxygen-rich blood is then pushed through your aortic semilunar valve into your aorta when that left ventricle contracts. Keep in mind that that ascending aorta not only is going to feed your rest of your body, but this is also where we'll feed that heart muscle as well through your coronary arteries. We'll get to those capillary beds wherever they may be in your body itself. Okay, so pretty much anywhere that isn't your lungs. And here we'll drop off the oxygen so that your cells are capable of doing cellular respiration and making you lots of energy, and picking up the carbon dioxide waste product that is a result of that process. We'll then push that oxygen poor blood, right? So less oxygen, more carbon dioxide now, back from your body tissues, either through your inferior or superior vena cava, depending on where the blood is coming from. Again, anything basically above your diaphragm is going to come back and empty into your superior vena cava. Anything coming from basically your diaphragm down is going to get fed into your inferior vena cava. All right. All of that oxygen poor blood from that superior and inferior vena cava flow into your right atria. Okay. That right atria will also return blood from your coronary circulation. And at this point, that right atria contracts, pushing that blood back into that right ventricle through your tricuspid valve. And we're back to the beginning and we repeat the cycle again. So this is kind of a just nice, really short, simple schematic, right, where it goes. So right atria, right ventricle, left atria, left ventricle. So here's your heart, right? We push into your pulmonary circuit, back to your left ventricle, push it out to your systemic circuit. Either we go up or down depending on what we're feeding. That goes out to your major organs, to your limbs. We return all of that back to that right ventricle and the cycle starts all over again. Not that I'm going to ask you to memorize all of these arteries and veins, but if you know a few of them, it doesn't hurt. So again, you've got your major arteries on this side. So here is your aortic arch. Right here is your descending aorta, goes down into things like maybe you know your femoral artery. That's a really big one that goes kind of through your groin. Definitely not one you want to nick. You bleed out pretty quick there. All right. If you know your major bones, then tibial arteries hopefully make sense up here. A lot of kids will know their carotid arteries in their neck. That's usually the one that we look for to feel a pulse. All right, so if you take it, basically take your two fingers, follow your jawline down from your ear, and you should be able to feel your pulse right underneath your jawline, and that you're feeling those carotid arteries. You've got some major abdominal arteries, okay, so on and so forth. So just some kind of cool ones. If you get to know them, that's pretty neat. You also have your radial artery and your ulnar artery. Those come down here in your wrists. If you're good, I always have a harder time finding this one, but you should be able to bend your hand back and feel your pulse there as well. All right, and you're feeling through those arteries there. And then your major veins. Again, very similar oftentimes in naming because of location. So you have your inferior vena cava and your superior vena cava right here that run right along the same line as your descending aorta. You do have a femoral vein, just like you have a femoral artery. And then in your neck, we talk about your jugular veins as opposed to your carotids, but they basically run right next to each other. Okay, let's talk real quick about coronary circulation. So again, your heart is mostly muscle. That means lots of mitochondria because we've got to contract. That's going to take energy. which means we need oxygen. Where's that oxygen going to come from? Well, it's going to come from your blood, and it's going to come getting there via circulation. Um, so your aorta is going to feed the bulk of this. That's going to go into your right coronary artery and into your left coronary artery, which is what you're seeing here. Okay. And then those break down into smaller arteries and eventually get returned to cardiac veins to your coronary sinus, which is sitting in your right atria. Anytime these guys get blocked, that's a really, really big deal. You're now not feeding a certain portion of your heart with oxygen, and that heart muscle dies pretty quick, which is one of the biggest things that we get concerned with when we talk about things like heart attack. How much heart muscle loss do you end up with? Because your body's not really good at replacing muscle cell quickly, especially this cardiac muscle. It doesn't really get replaced once you have it. So we want to make sure we keep it healthy, keep it functional, because once it dies, you end up losing some function as a result. If you take a look at the vein side of things, these are just some of those major components. Again, we feed your coronary sinus, which then empties back into